A point moves with d acceleration along the circle of radius r so that at any moment of time its tangential and normal accelerations are equal in moduli. At the initial moment t is equal to 0, the velocity of the point equals v naught. Now what we have to find? We have to find the velocity of the point as a function of time and as a function of the distance covered s. And the next part, the total acceleration of the point as a function of velocity and the distance covered. Now what we are given with? A point that moves with d acceleration along a circle. This means that the speed of the particle is decreasing with time. So I will put a negative sign, and this rate of decrease of speed with respect to time is called tangential acceleration here. Clear? So this is the first information that we can get from here. And the radius of the circle is r, and at any moment the tangential and the normal accelerations are equal. The tangential acceleration and the normal acceleration means the centripetal acceleration. You can denote it by an or ac, it's your choice. Clear? The moduli of both are equal, it is given. And vt is the magnitude of the velocity at any instant of time. Means velocity magnitude at any instant of time. And at t is equal to 0, at t is equal to 0 means initially it is equal to v naught, it is given. Now what we have to find out? We have to find out the velocity of the point as a function of time. So we have to find this vt, where initial velocity is v naught, and we have to find velocity as a function of distance traveled. Let s is the distance the particle has traveled in this given time t. So in the first part we have to calculate this at, this tangential acceleration is minus dv by dt, and this at is equal to this normal acceleration. Now this normal acceleration is equal to, this is equal to v square by r. So we can write v square by r. Clear? Now from here if we rearrange it, you can write minus dv by v square, and that is equal to 1 by r dt. Now if you integrate this equation on both sides, if you integrate it on both sides, from the limit time t is equal to 0, and when t is 0, initial velocity is v naught, and the final velocity at time t is, say, vt. And solving this, we get minus 1 by v, limit is from v naught to vt, is equal to t by r. Negative sign is also here, this is negative sign, so we have 1 by vt minus 1 by v naught, and that is equal to t by r. And solving this, we will get velocity as a function of time, which is equal to v naught r divided by r plus v naught t. So this is the answer to the part vt. Now in order to calculate vs, we will use this same result. Now from here we will write minus dv by dt into dx by dx, and that is equal to v square by r. And we can write this as v that is the rate of change of position with respect to time. So from here we have minus v dv by dx is equal to v square by r. So this one term gets cancelled, and from here we can write dv by v is equal to minus dx by r. Now again integrate this equation on both sides and putting the limit. X is changing from 0 to s, and v is changing from v naught to velocity as a function of distance. So from here we can write log e, because integrating this we will get log e v lower limit upper limit equal to minus 1 by r into s minus 0. And if you put the limit here, you will get log e v s divided by v naught is equal to minus s by r, and solving this you will get velocity as a function of s, that is equal to v naught into e raised to the power minus s by r. So this is our result of this part, velocity as a function of s. So we have finally calculated this first part of the question. Now next we have to find the total acceleration of the point as a function of velocity and the distance covered. The total acceleration a, let this is equal to a, is equal to the square root of the centripetal acceleration plus square of tangential acceleration. Also it is given that both are equal in magnitude, so we can write this as under root 2 AC, and we know that the value of AC is v square by r. So this first part, the total acceleration of the point as a function of velocity, we have calculated, and the second part, the distance covered, the total acceleration as a function of distance covered. From here we can write that a means the total acceleration as the function of v is under root 2 v square by r, and if we want to write this total acceleration as a function of s, so we will replace v, that is in term of s. So from this result, this v in terms of s, so we can write v naught square e raised to the power minus 2s by r, or you can write under root 2 v naught square divided by r e raised to the power 2s by r. So this is our answer.